We now have an example on stationarity and a hard limiter. A hard limiter is just a simple system, the input, and so you can say it's just an amplifier, a comparator, plus, minus, and then you compare it with 0. So the input is x of t, and the output is y of t. So y of t is equal to either plus 1 if x of t is positive, and if it is negative, it's going to be minus y of t. So a comparator or a hard limiter just compares the input, and if it is positive, it provides plus 1, or if it is negative, it provides minus 1. Now, in this system, probability that y of t is equal to 1, which is this guy, is probability that x of t is being positive. And obviously, this is a complementary CDF. CDF of x of t at time t. Similarly, if you want to calculate probability of y of t being equal minus 1 is equal to the CDF of x at time t. If you want to calculate mean of y of t can take only one value. So this value is going to be equal to the first value that y can take is 1, and times its probability, which is calculated here. And the other value that y of t can take on is minus 1. So this is minus 1, the next value, times its probability, which is calculated here. So if you add them together, simplify them together, you can get the y of t. So you get, obviously, if x of t is a continuous type random variable, this guy is equal to this one, and then you get 1 minus twice the CDF at time t for x equals 0. So if you want to calculate y of 2, this is equal to, you take the sample at this time plus t, and then you take the sample at time t. So you need to calculate probability that, because this guy can take, these two guys, they have 4 possible values, and then you have to calculate those 4 probabilities and then add them together. So we say summation of plus minus 1 times plus minus 1 and those probabilities. So or you can say that these two guys are either plus minus 1, so the probability of this one minus probability of this one, and then you can calculate. So hard limiter, if the input is a 0 mean wide sense stationary normal input, can be used to calculate the autocorrelation function of the output. So assume that x of t is given to hard limiter. The output of y of t, this is a random process which takes only value plus minus 1. So this circuit is a very simple electronic circuit. It's just a comparator. Obviously, if you give these, suppose that this is wide sense stationary and it is also normal. For instance, thermal noise, if you have an electronic circuit, thermal noise, you have this one. And suppose that you know that this is 0 mean. And autocorrelation of these Rx, x of 2 is something that you don't have, and you want to build a circuit to calculate this one. So in that case, we know that if you take 2 samples of x at time t plus 2, this will be normal, and then the mean of them is 0, and then the cross correlation, and this is the cross correlation between them. So probability that these two guys is bigger than 0, easily you can calculate, and this is equal to this guy. So this is what you can calculate. Now, And probability that this is negative is going to be 1 minus this, that you will get this one. So from these ones, if you give it now to a hard limiter, then the cross correlation of them can be easily calculated. So in that case, RY of tau is going to be, because this is going to be probability plus 1 times this one plus, and then if you add them together, you can calculate this one. Now what's going to happen is that I could give this x of t to this hard limiter and then get y of t, and then I can put a delay of 2. I get y of t minus 2, okay? And then because these two signals are binary, I could multiply them together, or I could just XOR them, which is multiplication, and then give them to a low-pass filter. So a low-pass filter is like an averaging. So it's going to give me roughly this guy. So this circuit is quite often used to calculate RY of tau, which is related to autocorrelation of the input. So it's a very simple circuit which can calculate the cross correlation between x of t and y of t. So this function is called arcsine law. So this arcsine law can give you the cross correlation of the two samples. So you don't need to have any multiplier or complex circuit. You need to have a simple hard limiter, an XOR, and a low pass filter.